Here's a common problem. We need to activate one-time use electronics once they're in place with limited access. Maybe a medical or industrial device. It needs low power in the quiescent state so it can sit idle for a long time. Once activated, it needs to supply higher current. Here's the circuit. We used an ultra-low power GMR switch sensor. It's duty cycled to reduce power and latched to ensure the output state is correct when the duty cycle is off. We can power it with a 3-volt button cell, but we need another layer of latching for this demonstration. For that, we're using a dual CMOS NAND gate connected as a set-reset flip-flop latch. The flip-flop is reset on power-up and latched when the sensor is activated. An LED serves as the load, but it could drive any circuitry. The sensor draws a maximum of 0.24 microamps, and the CMOS gate draws a maximum of 0.5 microamps. So the total quiescent current is less than a microamp, and the battery will last years until the circuit is activated. Let's test it out. We have an off-the-shelf sensor evaluation board, and we added a CMOS latch board. The resistor and capacitor are the power on reset. We put the assembly in a bag and put the bag into an ice cube tray. We add water and put it in a freezer. It's frozen. The battery wasn't depleted, and we can activate the circuitry with a magnet. The light goes on and stays on. Medical grade versions can be used to activate limited access medical devices. The activated circuitry could transmit data or perform some other function. These sensors are low power and ultra miniature. There are several options for the activation field. Contact NVE or visit nve.com for more information.